Hi everyone, we are back, and today we are going to do our pre-lab activity for a data set that I'm very excited to be looking at, which is our Bigfoot data set. Um, so we are going to basically run a chi-squared analysis on basically a contingency table. So we're going to build a contingency table, and we are going to analyze if these variables are linked. So specifically, we're going to look at Bigfoot sightings. So the number of Bigfoot sightings in the whole West Coast. So we're looking at California, we're looking at Oregon, we're looking at Washington. So we're going to look at the number of sightings, and then are they correlated? Are these variables correlated to season? So fall, spring, summer. So that's going to be our critical test today. And remember, our null hypothesis is that basically our null hypothesis is the variables are independent, they are not correlated. So if our p-value is greater than our alpha, we are going to say that they are independent and not correlated. If they are less, then if it's less than it, then they are statistically significant and they are therefore correlated. So let's go ahead and let's take a peek at this data set today. So we are going to go in and we're going to set this as our working directory. We are going to read in our functions, and let's take a look at our Bigfoot data. And there's a lot of cool things. This is all data sets that's available from essentially the tidyverse. You have to read some of these. You'll get a kick out of them. Although Bigfoot does exist, I believe. Apex predators. But anyways, so we have states, we have seasons. So we are going to filter based on these parameters and essentially do a count. So I'm going to go ahead and we're going to take BDAT, and I'm going to filter it. Okay, filter. I want where state is set equal to California, and I can see all the good data sets there. And I want to subfilter that based on, and I'm going to pipe again. Type function, filter, season, set that equal to fall. So I'm going to grab that. Oops. It doesn't like it because I need it that way. And we've got that. So I'm going to call this a variable California fall, CF. And I want to do my CF. I could look at dimensions. Actually, I'm going to do that right there. I'm going to do another one. Dimensions of this. I'm going to pipe that into my CF. And I can now look at my CF value. So CF, I have two dimensions. And if I look at that data set here, where is my, no, it's my variable here. But CF is going to have 102 rows and 28 columns. So I know that there, in fall, there were 102 sightings of Bigfoot in California. So that's going to be my data set. So now I'm going to go and do the same thing for California in the fall, spring, summer, and the same thing for Oregon and Washington. I know that it is, and I've heard the feedback that it's great to see me type over and over and over again, but instead I'm going to do this. So this is just copy and pasting and getting all those values in. So nothing too exciting about this data set. Now, what is exciting is when we actually go and start to type in, actually create our values. So I'm going to do my data. I'm going to set this as a variable, and I'm going to do a matrix, and then I'm going to do also my C, and I'm going to read in now CF of 1, CS of 1, C sum. I'm just reading in the numbers. So C sum, OF 1, OS1, O summer 1, Oregon. And then I'm going to do Washington fall 1, Washington sum, Washington WS1, W sum 1. Excellent. And I'm going to go ahead and state that this is my number of, actually, end calls, excuse me. End call equals 3. We're going to have 3 columns, and then n row, or actually by row is true. By row equals true. And we'll have the data set. I'm going to set my call names. I'm going to set it equal to, actually, call names, excuse me. call names in my data. I'm going to set it over here, and I'm going to do C of California, Oregon, Washington. I'm going to change this to just a single. Yeah, it always does that. I'm going to delete the whole thing or restart. It's one of my pet peeves about. So there we go. Call names. I'm going to do row names. Row names, and we're going to do fall, spring, and we're going to do summer. And then I'm going to do my data goes to as.table of my data set. And we can now look at our data. And we built our contingency table. So this is great. And it's nice. So we've got our contingency table. Now I can do chi-square test. You can look at the differences. This is your chi-square test. So I could do my chi-square test of my data. And we have our results. So I can see that my p-value is going to be much less than my 95%, my alpha, which is going to be 0.05. So these, we're going to reject the null hypothesis. These are indeed correlated values. So the variables are indeed correlated. So that is excellent. So we see there's some correlation. So we'll see you in the next video. Thanks. Bye.